These are the video notes for section 6.2, factoring basic trinomials. We have 5 steps. The first step is to order the polynomial if necessary, factor out the GCF if possible, write factor pairs for last number, write a math expression with both signs that equal the middle number with its sign, and lastly, set up parentheses with variable in front of each and math expression at the end of each. Similar to our previous lesson when we were factoring out the GCF, I'm going to show you what we're going to do, but going backwards. You know that to simplify two binomials, we have to distribute each part of the binomial to this binomial. So we get x squared minus 7x plus 3x minus 21. Then we combine like terms to get x squared minus 4x minus 21. In today's lesson, we're going to be factoring this trinomial. So the problem is going to look like this, and we're going to end up with this as our answer, 2 parentheses. So this is called factoring. If you notice, today's lesson is called factoring basic trinomials. I call a basic trinomial when there is no number in the front other than 1 in your trinomial. So if there's another number in front there, like 2, I consider those harder trinomials, which is our next lesson. So in our first example, x squared minus 4x minus 21, we're going to factor it. We don't have to put the polynomial in order because it already is. Then we're going to factor out the GCF if possible. Since there's no GCF between the 3 parts, we can go ahead and write the factor pairs of the last number. When you write the factor pairs of the last number, don't include the sign that is there. So we're just going to simply write a 21 off to the side. The factor pairs of 21 are 1 and 21, 3 and 7. Then the next step says, write a math expression with both signs that equal the middle number with its sign. So the middle number with its sign is a negative 4. So of these two, we need to get them to become a negative 4. The only possibility to become a negative 4 is by using a 3 and 7. So what we're going to do right now is we're going to create the math expression that would get us a negative 4, and we're going to put the sign in front of both the 3 and the 7. So we need to have a positive sign here and a negative sign there. So positive 3 minus 7 gets us a negative 4. So we've pretty much done most of the work. We now have to put our final answer the way we know how. We know that we're going to have 2 parentheses, so I'm going to set up my 2 parentheses. Whatever variable you're working with, you're going to put it in the front, but you're only going to write it as a single variable to the power of 1, because when we distribute x and x, we want to get an x squared out of it, so we're only going to write x in the front. Then you're going to take your math expression. We have a positive 3 and negative 7, so we're going to write that in as plus 3 minus 7. And now we have factored x squared minus 4x minus 21 into x plus 3 times x minus 7. Now some people might be concerned that when they write their factor pairs, they write 7 first and 3 next, and they would put the signs in, and then their answer would be instead x minus 7, x plus 3. These two answers are actually the same because multiplication is commutative. X plus 3 times x minus 7 is the same as x minus 7 times x plus 3, just like 3 times 7 is the same as 7 times 3. So either answer is okay. In our next example, 12 plus 7x plus x squared, we need to put it in order. So x squared plus 7x plus 12. There is no GCF, so I'm going to skip right to writing the factor pairs of 12. The factor pairs of 12 is 1 and 12, 2, 6, 3, and 4. Now I'm trying to get a positive 7 out of it, and the only one that can get me a positive 7 is the 3 and the 4, so I'm going to exclude these 2 factor pairs. The only way to get a positive 7 is if I have a positive 3 and a positive 4. So now I'm going to set up my parentheses. X goes in the front, and then plus 3, and then plus 4. In our next example, we're going to factor out the GCF. The GCF is 2, so I'm left with x squared minus 14x plus 48. If you notice, the problem looks a little different now because there's a number out here in front. What we're going to do is we're going to factor this trinomial, and then in our final answer, we're going to bring down the 2. So I'm going to write the factor pairs of 48 which is 148, 224, 316, 412, and 6 and 8. We're trying to get a negative 14. The only factor pair that would get us a negative 14 is 6 and 8. So I'm going to write negative 14, and then the signs would have to be both negative. So to factor this trinomial, we will have x minus 6, x minus 8. And then we're going to bring down the GCF that we factored out earlier into the final answer. In our next example, we're going to jump right to writing the factor pairs of the last number, which is 1 and 12, 2 and 6, 3 and 4. We're trying to get a positive 10. If you notice, all of our factor pairs, none of them would get us a positive 10. So therefore, this problem is called prime. Or in other words, unfactorable. In our next example, we're going to factor out the GCF, which is negative 1. We're left with r squared plus 12r plus 36. Then we're going to write the factor pairs of 36, 1, 36, 2, 18, 3, 12, 4, 9, and 6 and 6. The only factor pair that we're going to use is 6 and 6 to get us a positive 12. We're going to write our signs in. Then we're going to factor the variable first, plus 6 and plus 6. In our last example, we're going to write the factor pairs of 6, which is 1 and 6, and 2 and 3. For this example, we're trying to get a positive 5. If you notice our factor pairs, both of them actually would give us a positive 5. If the signs for here were plus and plus, and the signs here would be plus and minus. So both factor pairs actually give us positive 5. So what we do in this case is we're going to pretend that both are correct, and we need to check which one would give us the x squared plus 5x plus 6 if we were to use both. So the first possibility is x minus 1 times x plus 6. So now we're actually going to simplify this to see if we get back our original trinomial. So I'm going to distribute the x and then combine like terms. Since x squared plus 5x minus 6 does not match our original problem, we know that this factor pair, 1 and 6, does not work. So now let's just double check to make sure this is correct, even though process of elimination would tell us that it is correct. We have x plus 2 times x plus 3. We're going to distribute and then combine like terms. And then indeed we find that this actually matches our original trinomial, so we know that to factor x squared plus 5x plus 6, we get x plus 2 times x plus 3.